Hi friends, in this tutorial I'll be showing you how to write a BMP file format. For example, at the end of this tutorial we will have a BMP file which when compiled will give us executable, and we can pass arguments to this executable in the form of width and height. So when we execute map file, bitmap program, it will with arguments width and height, let's say 640 and 480, it will give us output image1.bmp. If I open that file, we should be able to see something like this. We should be able to see something like this output file, either this or here I have created image1.bmp. Yeah, we should be able to see something like that. So let's get started with the first. We'll briefly understand how the BMP file format looks like. So it will have header which is of size 14. It will contain some details like BMP 2 bytes for just to show it's a BMP file. Then we have 4 bytes which will tell us the whole size of the file. Then these are reserve bytes. Then we have offset. So from the beginning of the file, where is our data starting, bitmap data starting? That offset will be, we can read here. Then we have info header. Info header will contain information details. This header is of 40 bytes. So first it is showing us the size of the info header, that is 40 bytes. Then we have 4 bytes for width of the in bits per bitmap in pixels. Then we have here it will be 640, and then we have height of the bitmap in pixels, that will be 480. Then we have a number of planes, we can ignore this. And then for each pixel, how many bits we are using. So in our case, we will be using 24 bits. Per color, it is 8 bits. Hence, it is 24 bit for RGB. Compression, we can ignore. Image size, it will be, we can ignore this as well. And color table, we are not using. These things we can ignore for now. And after info header, file will contain pixel data. Now that we understand BMP file format, let's get started with the understanding how the program looks like in C. Let me open the editor. Yeah. In this tutorial, I have already written the program, so I'll just walk you through the whole program, how it looks like. Let's first see how the header file looks like. This is, so as we have seen, we have file header and info header. Yeah, if you see this struct bitmap file, it will contain bitmap file header, and we also have a struct for info header. In the file BMP file, we will have after file header and info header, we have actual data of the file that we have represented it as pointer data. And let's see the how file header looks like, and next we'll see how info header looks like. So I'll open file header. So struct our bitmap file header looks like this, exactly what we had seen in this link. uh, so same thing I have written here: signature, file size, result, and data offset. So if you see the structure, it has file signature 2 bytes, then file size of 4 bytes, reserved of 4 bytes, and data offset is of 4 bytes. This is the header file for bitmap file header. Then we'll see how the info header file looks like. So this is exactly this structure is of bitmap info header, and it contains the fields whatever is given in the this link. If I see bitmap info header, it has these same things: size, width, height, planes, bits per pixel. So it contains those same things: size, info header, width, height, planes, bits per pixel, compression, image size, X pixel per meter, Y pixel per meter, colors used. These are not used by us. So yeah, this is the structure of bitmap info header. Now that we have seen bitmap file header structure, then we saw bitmap info header structure. Let's go and see how we can use these two things have been put in this bitmap file structure, which contains nested file header, info header, and pixel data. Pixel data is in the form of RGB. Let's go to the main where these will be used. So here in main, I have first we need to get the arguments from the command line. Our command line will be like this: bitmap, width, and height. This is the example. So we need to parse the arguments width and height, and the total arguments will be three. One is the program name, second one is the width, and third is the height. If arguments are not exactly equal to 3, then we need to throw an error and return. When we get the input, it is in the form of character array, so we need to convert it into integer. That's why we are using a to I function to convert character array to uh, width. So this will convert width from character array to integer, and the next function will convert height from character array to integer. Now that we have got width and height, the next step is to start filling the file header. So as we have seen in the file header, we need to write file signature, file size. This is the result, we can ignore it, and the data offset. So let's see how we write that. Here there are some things which we can ignore for now and will be discussed later. This is basically padding. It's required at the byte level. So let's start writing the file headers. So as we have seen, we need to write header, data, info header. And third, this we can ignore, not required for us. And the last is pixel data. So let's first start writing file header. So first we need to write the signature, that is for BMP file format, it is BM. Then we need to calculate the file size, total size of the file, which is equal to image size plus size of bitmap file header plus size of bitmap info header. Result is 0, we don't use it. And then we have data offset from where the data actually starts. So that is nothing but size of bitmap file header plus size of info header. Yes. After which our actual image data will start. Next, we need to fill the bitmap info header. So info header structure is like this. So let's go and fill those details as well. So in bitmap info header, first is the size of info header. So the right size of bitmap info header. Then we have width in pixels. Next is height in pixels. Next is planes, we don't use it. And bits per pixel is 24 bits. That is RGB, 1 byte each. Compression we don't use. Image size, it is the size of the image. Only data, excluding header data. Then we have, these are not used. So info header, data we have filled. We have calculated file header, bitmap file header, and bitmap info header. let us try to create a variable for the file, bitmap file, that is image1. And image1 bitmap file header will point it to this. We'll copy this data, and similarly, image1 bitmap info header, we will copy the data which we have populated here. Here the file header and the info header data is directly copied into image. Next thing is we need to create image file and start writing this data, header data, and then the actual data which we need to write. For that, I will open a file with some name like image1.plt. I will open it in write mode, and because it's binary data, it is opened in binary mode. So if open, we will do with image1.cpp write in binary mode. And if this is successful, we will get a file handle in file pointer. File pointer is a pointer which we will use for reading and writing into the file. So after f open call, we will check whether our file open function was successful. If it is not, we'll throw an error and return. Else, we'll continue start writing data to the image. So once the file is opened, first we need to write the bitmap file header. So to write that, we need to pass file header and size, how much data we need to write. That is nothing but structure bitmap file header, and how many of these instances we need to write. So one file pointer to which file we need to write, that needs to be passed. If you want to see the signature of fwrite function, we can do a man file will use the d2. What are the arguments we need to pass, right? So if we see here fwrite function, you need to pass the pointer where the data is stored, what is the size of the data, and how many number of times you need to write this data. And last is file pointer where we need to write the data. Now that we have written bitmap file header and bitmap info header, now it is time to start writing the image data. Before starting to write data to the file, we need to create the data in memory. So to create the data, we need to allocate some memory. So for that, we have to use malloc function, and how much data we want to write, how many bytes we want to write. That is nothing but width into height into these many. This is the resolution of the image. But every pixel will contain 3 values, right? 3 bytes. That is RGB. So we need to multiply it with size of pixel. If you see here in the bitmap info header, sorry, here in bitmap header file, we can see here structure pixel is nothing but 3 bytes because of RGB values. Then, so with this malloc, we will get exactly the number of bytes we want to write for the image. Now this data is of type pixel, so we need to typecast it to pixel. So in that we use struct pixel star. So now we will use a pointer struct row pixel data for reading and writing into this memory. Writing image data, we can use a for loop for j equal to 0 to 8. This is one row. Sorry, means j variable will be used for. So the logic will be row pixel data column row into width. How many pixels plus I. That is nothing but which pixel on the x-axis, horizontal axis, and in that we want to value of blue, red, and green variables. So let's say initially I am writing it. Let's say we make it 0, blue 0, Green we will keep 255 and red also 0. This loop will populate all the pixel values, and we expect output to be of green and of size 640 and 480 pixels. But now once this data is written to this memory, now this memory data needs to be written to the file. So for that we will use, for that we should use fwrite. So let me just comment this line and let us use fwrite to write all the data from the memory, which is nothing but raw pixel data of size pixel, struct pixel, and how many of these pixels we have, nothing but width into height. These many pixel data we need to write, and the output file pointer is file pointer. So once we have written the data to the file, we need to close the file. For that we use fclose file close. And that is the end of the function, end of main. Let us now try to compile and execute the program. I'm saving the file. Then usually plus output. Let me first delete the old file. Right over the project. It has thrown an error. It says image size was not declared in this code. So let me just move. Yeah, few lines we had commented because I wanted to explain about padding later. Okay, let me just uncomment this image size and see if it works. Save, then compile. So row size is required. So I need to uncomment this line as well. Now padding is also required, so I have to uncomment this line. So I'll explain this later, but let me just compile for now and see how the output looks like. Yeah, so we were able to compile and we got the output file executable bitmap. So let me just run bitmap. Okay, so if I run without arguments, it has thrown incorrect arguments. We need to pass width and height as well. So let me pass width and height. Let's say 640 and 480. So now it should have created image1.plt. Yes, I can see that. And here I can see that. Yeah, if we see, it is green image. Let us try to open this output image in file explorer and see the details. You can see the details of it. It is 900 KB BMP file for that. And details, yeah, if we see it is 640 by 480 and bit depth is 24 bits. Yeah, that's all. We have got the output file. Now let's go to these three lines which we uncommented where we were calculating the padding and image size. So image size is nothing but row size into height. Correct. That is nothing but width into height. But row size, each pixel is of 3 bytes. That is nothing but struct pixel, size of struct pixel. We need to multiply it with width. That will give us the total number of pixels, bytes used. Along with that, we need to add padding as well. So what is this padding? So padding is nothing but while storing some values in compiler, some alignment. So let's say compiler is using 2 bytes alignment. then even if you write only one character in the struct, it will, while storing, it will use 2 bytes. Whereas 1 byte will have the data and 1 byte will be just padding. That is for memory alignment to speed up the data storage and access line. If alignment is, let's say, 4 bytes and you store only 2 bytes in the structure variable, then compiler will take 4 bytes to store the data. Whereas 2 bytes will contain the data and 2 bytes will be padding for the padding purpose. Hence, we need to calculate how many bytes are used for the padding, and those we need to add in row size because in each row that padding will be there. So how many bytes are used for padding? So in each row, we have to calculate how many it has to be. It is for alignment of 4. So how many bytes are remaining? Let's try to find out in one row, which is the nearest multiple of 4. So size of pixel into width. This is the number of bytes used for one row. If I mod it with 4, it will give how many extra bytes are there after alignment of 4. Let's say 1 byte is extra, then we need to subtract from 4. It will give us 3 bytes as padding. So here padding will become 3. And whatever that padding value is, it will be used while calculating the row size. And hence image size will be equal to row size minus, row size into height. Let us now try to change the variable values, RGB values, and see how the image looks like. Let me make red as again 255. Let me compile and run. It will overwrite the image file. Yeah, so it is yellow color. This explanation was useful for you to understand how to write a BMP file from scratch in C programming language. I will share the link of this code in GitHub in the description.